Shaun Langley. I'm senior programmer developer with Urban GIS. I was asked to speak today about utilizing open source tools and resources for GIS data, and to talk about how the CAD community can be benefited with some of these tools that are available. I just want to sort of step back a little bit, and I'm sure this is probably going to be a review for like many people, but let's just talk about what GIS is for a second. GIS stands for Geographic Information Systems, or Geographic Information Science, depending on who you ask. It's all about spatial information. So when we talk about spatial information, the world around us is spatial in nature. And when we, everything can be sort of parsed down into various types of information, whether those be, the roads that we drive on, the sidewalks we walk on, land use, how we choose to utilize the land. All of this information is spatial, and it needs to be handled in a very different way than we might be used to with other types of data streams. Why should we be concerned with GIS? What benefit can spatial data provide to us? Well, GIS provides a way for us to understand the world around us through different types of data visualization and analysis. The images here are an example of one of the projects that I've worked on. Let's see here. There we go. Here we go. All right. So this is just an example of one type of spatial data. This is a LiDAR image. It's a airborne collected data product that's based on lasers. And what we do here is we've created sort of like an aerial imagery of sorts by mapping by representing the intensity of the returns differently. What we can do with this is we can actually represent that in several different ways, that information. We can create a surface model of the Earth based on that information, and we can further process that to extract contours. So what we started out with basically a data set that is comprised of about 10 million data points, and we've analyzed it and processed it, and the end result was a series of elevation contours that we were able to import into AutoCAD for the client. And then they were able to use this information to support some of their watershed modeling that they were doing. GIS allows us to make plans, not only to understand the world around us, but then to use that information to change how we interact with it. This image is a satellite imagery. It was captured by a Landsat satellite, and it actually shows, I don't know if you guys remember the tornado that hit in April. I actually live like right here. But the tornado, it was an EF4 tornado, but you can actually see from the satellite imagery the track that the tornado took. These types of images help us to not only to understand the impact that these events have had, but they help us to evaluate our response to them and to adjust how we might respond to similar events in the future. GIS allows us to recognize patterns in the world around us that we may not be able to see otherwise. On the left here is an image. It's just sort of like a normal photographic image that you might see, and I think this is from Brazil. I'm sorry, I don't remember where it's from. I should remember. But a friend of mine actually did this. They collected LiDAR imagery of this area, and this is an archaeological site that they've been processing, they've been looking at, and one of the things they did once they were able to strip off the vegetation cover off the land through the LiDAR analysis. And one of the things that they discovered was this area just to the east that they hadn't, it was maybe a few hundred feet away from where they had been working for 5 years, and nobody had noticed this other additional site. But through the power of GIS, they were able to isolate these patterns and were able to make new discoveries that they weren't able to even when it was like right in front of them. This is an example of another. I'm talking a lot about LiDAR data. It's not all I do, though. This is an example of a LiDAR collected image of just a neighborhood. But what we're able to do is by representing the change in slope explicitly from one point to the next, we're actually able to easily extract certain features. So you can actually see building outlines that are clearly visible from this image. And we were able to create feature polygons from that image that we could then import into the CAD for the client. GIS allows us to identify patterns, but it also allows us to explicitly represent relationships between elements on the Earth. And this is really where GIS takes us that one step further. We can begin to ask questions about how one thing here is related to one thing over here, to evaluate that relationship and to explicitly represent it in different ways. So I just have a simple set of graphics here. You know, circle A can be contained within circle B. Shape A could touch shape B. It could be on top of it, could cross. They could overlap. There's these different spatial relationships that at a very high level don't seem to be important, but when we begin to evaluate them in the context of something specific, we can realize the importance that those relationships can have. One example that we've worked with is trying to map out different networks in the city. And we can begin to ask the questions, okay, I've got this light here, what's my nearest power source? And we may not have the connectivity represented explicitly, but we know the position of a light source and we know the position of all the power sources in the area. We can begin to query those relationships through these spatial functions. So where do we take this? How can we use the GIS tools to really augment what we already have? Well, GIS allows us to represent features in geographic space, and a lot of times we simply work within a Cartesian space, but that doesn't always translate very well to the real world. Once you go that next step and you change your coordinate system to be one that's geographic, it really allows us to represent things more accurately and in a way that's more translatable. We can augment our features with attribution that is available from GIS data. You may have representations of curbs in a neighborhood or something, but there may be some value in attaching certain attributes to those features that could be used for some other purpose. But one that's perhaps most important is that we don't need to recreate data all the time. We can extend our data through these public data sets, and that may allow us a way to create new data that's accurate but less time consuming. And then finally, we can add topology and build relationships between features, again, like I mentioned before. And that may allow us to identify features within a certain area, to build relationships between features. And our features can have directionality as well. And that's important, for example, if we are doing water flow modeling or trying to map out a watershed or something. That's just one example. I want to take a moment and just cover, I know that we all know how we can use GIS, but there's a lot of public data out there, and at times it can be difficult to sort of parse through all of that and really identify the most useful sites. And so I just put together a quick overview of the data repositories that I have found most valuable. I'm going to cover 6 of them here. The City of Chicago's data portal, OpenStreetMap, the National Climate Data Center, or NOAA now. I guess they've got rid of the name. Their climate data, the USGS's land cover and other derived products, and then the census data. There are many other. This is by no means a comprehensive list, but this is, again, just ones that I've used most frequently. All of these, I have links to all of these at this website, and there's also a copy of this presentation is available as well. I'll give you the URL later. All right, the City of Chicago actually is not alone, but is fairly unique in the volume of data that they make available publicly. And it's open data. It's free to use, incorporate. They have more than 200 data sets that comprise information across all departments in the city, services. They have information from transportation. They've got different building data, public safety, economic data. I mean, there's a ton. One of the things I love the most is that they actually have an open data. They use the Socrata Open Data API, which means that it's really easy to interact with that data. And I have an example of that. So they may also maintain a GitHub as well. One of the things that they have is this little R script that they use to, it's just, they create a simple map of the crime data that's made available on the site. So all they do here is that they bring in the data in a CSV format, and it's just, they make this data available in many different formats. This example just uses the CSV. And then they just create a simple pie chart. Now this is not, you might think, okay, well this is not spatial information. True. One of the things that's in the CSV that isn't being mapped here is the location of these crime points. And so I can actually go one step further here, and what I did is I created a map where I isolated one specific type of crime, arson, and I'm looking at all occurrences of all arson since 2001, and I created a heat map, which is really just an analysis of the analysis of the frequency of points in a specific location. This type of analysis can actually be really useful. You might be looking at this area of the city and you say, oh, it looks like I have a really high density of points in this area. Well, hey, I wonder what's going on. I wonder if there's some sort of if there's some relationship between those arson events. It might be a single individual. Police can use this to begin to look at their data, identify patterns, and make sense of the world around them by visualizing the data in different ways. OpenStreetMap is another great tool. This is a map of the Northern Illinois University campus. Happen to live just over here. And this is a collaborative GIS community mapping project where people can go in and create features themselves, create annotations and attributions to features. This data is available. You can download it in XML format, and I know that CAD can actually import this without any processing. But this is a way to get all sorts of information that, building footprints, stuff like that, complete with all that attribution attached to it that may not be available otherwise. The NCDC climate data is an interesting data set that I've had an opportunity to work with. This data set, they have like 35,000 weather stations. Some of these stations have been providing temperature data since 1901. And I was silly enough to download the whole archive. It was like 6 billion data points. And, but there's this huge wealth of information there. It's very difficult to process when you have that volume of data, but depending on what kind of information you're looking for, this could be a good resource. The integrated surface data set, which is just the hourly temperature data, is just one of many products that they make available here. The USGS land cover, again, they have the Land Cover Institute is one run by the USGS. They provide many different types of products. These are all MODIS-based products. They offer things from vegetation, climatological, ecoregion, fire mapping, all sorts of products that are available. These are available either in shapefile format, GeoTIFF format, amongst many others. The U.S. Census Bureau has, for a long time, made their data available through the as many of you probably heard of the Tigerline product. They provide all sorts of information about economic conditions. Pretty much any information that they've gleaned from the census is made available freely from their website. And many of that can be incorporated into your data or into your projects. USGS also has a huge volume of data that's made available as well, including aerial imagery, LiDAR data, land cover data, the Landsat multispectral imagery, which is the Landsat 8 one that I showed you before, was acquired from here. And these, primarily, they're all raster-based data products, but again, there's this huge volume of data that, again, is available for all of us. So, okay, we've got all of this data. So how can we use it? Well, again, I kind of came to programming from the open source world, and so this is very familiar to me. This is what I like to do. Python is perhaps the go-to language these days for geospatial data analysis and manipulation. And there's a huge volume of libraries that are available for us to interact with this data. This is just a short summary of some of the packages that I have used, but again, is by no means comprehensive. All of this is available with some sample code at the website there. But I'm just going to cover a few of these, and then I'll provide some examples of how I've used these packages to work with GIS data. So PyShape is a package that's used to read and write Esri shape files, which is a common data format for vector data. Shapely is another one used to interact with vector data. GDAL is sort of a whole suite of tools that are available for working with raster or vector data, and is my preferred way of doing data translation and manipulation. PyProj is a tool that can be used for spatial reprojections and spatial transformations. I have an example of that later on. And ArcPy, this is one. This is sort of the one oddball out here. This is not open source. It's ArcPy is really just a Python add-in module that allows us to interface with the ArcGIS desk suite of products in a Python environment, which may or may not be useful, but depending on how you're working with your GIS data, you might find it useful. And then NumPy is not necessarily spatial in nature, but I've used it frequently to represent and interact with that spatial data. Okay, so here's an example of how I've worked with ArcPy and PyProj in order to do some spatial transformation reprojection. So, I don't want to go, I don't know how much detail necessarily to go into, but basically you can see here that, I just have my projection string here that translates me from the geographic projection system into the NAD83 projected space. And what I was able to do with this is I was actually able to loop through all the data here is stored in a Postgres geodatabase, and I like to work with the data directly. I don't necessarily always like to do things. I like to do things sort of at the core, if you will. So what we were able to do here is we were able to actually extract the x and y coordinates from that shape directly, and then we were able to pass those through this reprojection function here, and I was able to then store the latitude and longitude without having to reproject the whole data set. So then, and this is one of the strange things, that the client wanted both the data stored in the projected system, but then they also wanted the latitude and longitude stored as attributes in that table. And aside from having to frequently go back and forth between changing the projection system, this turned out to be a really useful tool for us. The ArcPy suite allows us to interact with data stored in ArcGIS, and while not necessarily open source, is really useful sometimes. This here was a project that the client wanted us to calculate spatially weighted averages of these parcels, and so I was able. It was something that was actually very difficult to do with the tools available in ArcGIS, but with Python it was actually really simple. All we had to do was to loop through, sum up all of the different components, and then divide to calculate a weighted average. And then so we just looped through these things and then stored them in the final product. Spatial data is obviously comes in different formats, and one of the formats that has been historically very difficult to work with programmatically has been raster data. I was involved with this project with one of my former colleagues at Michigan State University. This was a project that looked at the efficacy of storing raster data inside a database, not in just a blob format, but in a way that actually gives us access to all sorts of spatial functions. So this project was really about trying to measure the performance differences between working with data in a file-based format, in an out-of-database model, versus storing the data in the database, and the performance improvements that you see from that. So, this I show this specifically because it uses some of the open source modules that we looked at previously. This uses the GDAL package, and it uses the NumPy package. Again, NumPy is not necessarily spatial per se, but it does allow us to work with n-dimensional arrays. And when you're talking about raster data, that actually is a very good way to represent the information. And so, I won't go through this necessarily in detail, but basically we loop through all of the files, and we first read them in using GDAL, and that allows us to essentially get that information, extract that from the GeoTIFF, and represent those values in a three-dimensional array where we have x, y, and then elevation as our third dimension. And this script really was just about retrieving all of the data and then patching it, stitching it back together for a specific location. You can see it was quite involved, 3 slides. When we put this in the database, it was actually quite a bit simpler because we were able to leverage a lot of the spatial functions that made available in the database directly. So, for example, I can query all of the raster files, the raster tiles which are split up. I can patch them back together just with a simple neighborhood function. But then I can also create geometries on the fly, from text. And so what I did is I just wrote this function that allows me to pass in an x, y value, and it converts that to a point, and then it returns a variable window where that point intersects with the raster data. So this is it turned out to be quite a bit more. It was a significant performance increase, but I think more than that, it was just a lot simpler to interact with the data. There are many different tools, resources that are available out there. Again, these are some of the resources that I frequent. I think my favorite, which is Stack Exchange, they've got a really great subsite for GIS questions. I think more than that, that's the one I go to 90% of the time. A couple of books that I've interacted with that I found particularly valuable. I have links to all of them, and you're welcome to grab a copy of this presentation. The URLs are right there. Just click on them.